This video is about arcs, sectors, and segments of a circle. Okay, so we've got area of a circle, which is pi r squared, and we've also got circumference of a circle, which has the two formulas, but they are essentially the same because 2 lots of the radius is the same as the diameter. So it's just your preference to which one you want to use. Now, when you've got areas of a sector or you've got arc length, what you're essentially doing is doing the area of a circle or the circumference of the circle as normal, and then timesing it by the angle over 360. And what that does is like essentially gets the fraction of that whole circle of what's actually being used. So we've got about 4 or 5 different questions, can't quite remember, to go through. And this is the first question, so pause it if you would like to try it out yourself. I'm essentially just going to go through them straight now, so just to see how they're done, okay? From A to C, we've got the diameter, which is 120. This means that this part going straight up is the radius, which essentially is half. So the radius of these is 60. Now, the question is looking for the perimeter of the shaded region, which is badly drawn, but this section by here. Because we're going halfway, we know that that is also 60. Now, we need to work out the arc length of this section. Because we've got a quarter or half of that semicircle, it's essentially, we're looking at 90 degrees by here. So firstly, I know that section that I was talking about just a minute ago was 90 over 360. So just writing that down straight away. Some of you might have just said, oh, well, it's a quarter. That is fine too. It's the same thing. And then what we're going to be doing is timesing it by, because we want this, essentially the circumference of the whole circle. So remember that's pi times diameter or 2 pi r. I'm going to go diameter because it's easier. So I've got 120 pi. When you put them into your calculator, you'll get the answer of 30 pi. And remember, that's just that bit of the arc. So what we need to do now is add on that 120 with the 260s being added. So 30 pi plus 120. And that's going to give you 214. I can't quite remember the rest. Oh, 2, 4, and then it carries on going. And because he wants it to 3 significant figures, our final answer is just 214, because when we rounded up the 2, it goes down. Ooh, there we go. Next question. It says, show that the length arc AB is 5.24 centimeters to the 3 significant figures. One of these questions, because it's saying show, I would show all your workings. It's given us the answer already, so it's not wanting us to work out the answer. So I'd write down what formulas you're using and just make sure you've covered all your bases. So I know it's going to be angle over 360. And then I'm going to do 2 times my radius times my pi. So I'm using essentially the other formula now, but it doesn't really make a difference. So the angle is 50 over 360 times by 2 times by 6 pi. Type that into your calculator, use the fraction button so we're not making any mistakes. Times 2 times 6 times pi, which gives us 5 over 3 pi. SD that, which gives you 5.235987756. You don't have to write it all, just write a few numbers. I just decided to go rogue. And then rounding to 3 significant figures, well, that's going to give us 5.24, as that 5 will round us up to the 4. And there's our centimetres. So that's the second question done. Next question we've got by here is looking at the area of a sector. So again, pause this question if you need to, but I'm going to start straight away. So the area of the sector is 8 centimetres squared. Now, let's think about the formula. So the formula would be angle over 360 times by pi r squared, because that's the area of the circle that we like to use. And I'm going to fill in what we know. So we know 120 over 360, wow, times by pi r squared equals 8 centimeters squared. Do a little bit of rearranging here. Okay, so when you've got that, that's the same as me writing a third times pi times r squared, and that gives us 8 centimeters squared, which is the same as me saying pi r squared is 8 times 3, which is 24. R squared is going to be just 24 divided by pi, which we can work out, which gives you 7.639, blah, 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 blah. I'm just going to keep that in my calculator, and I'm going to square root that then, just give me r on its own, which is 2.76 to two decimal places. And there we go. If you have time during the exam, please go back to this question and just retype it in the other way around. So put your radius in, just check that you get that 8 centimeters, just so you know you're guaranteeing yourself those marks. Okay, the questions are going to get slightly a little bit more difficult, but nothing too challenging. So this one, we've got 2 sectors and they're on top of each other. Okay, so we've got the white sector and then we've got the essentially a shaded sector that might be underneath it. So the first thing I need to do is I need to work out what the finding out the perimeter. So I need to find out the perimeter of this long arc and the perimeter of this short arc. So we're not going to be taking anything away in this question, so that's a key point to know, apart from the fact we will need to find this length by here. I think that's the only thing we actually need to take away. So we've got 6, take away 3.5, that leaves us with 2.5. And now essentially I've got 2 arcs that I can work out. So I'm going to say this is my number 1 and this is my number 2, just so you've got an idea. Also, the fact that that is 3.5 means this one is also going to be 3.5. So just remember that as well if you get a little bit stuck. Okay, so the first one, we're going to do 45 over 360 times by 2 times by radius, which is 2.5, and then times that by pi. So let's work that out first. Times 5. That gives me 5 over 8 pi. And I'm just going to leave it like that because I'm going to have to do more workings with other pi. So there's no point rounding at this point. Number 2 is essentially the same, but this time I've got 6 instead. Please don't use 3.5. It's there to not trick you, but you might use it because it's the whole length, which is going to give you that arc part by there. Okay, so times by 6 times by 2 times by pi. If I put that all in the calculator, and again, if you've already got it in your calculator, you can just use your arrows and work backwards. That's going to give me 3 over 2 pi. So that's 1 and 2. Now I know that these two are 7, so I've got 7 plus 5 over 8 pi plus 3 over 2 pi. So I'm just going to add them all together. Plus 7. And it was, so my answer to that is 13.67588, and then it goes on. So I can just round that to 13.7 because it's 3 significant figures. And that's that question finished. So we've got 2 identical quarter circles that are cut out from the rectangle as shown. Work out the shaded area. If you would like to have a go at this, pause it, and I'm just going to go straight away. So first of all, rectangle, and we're looking at the area of that. So that's going to be 12. If remember, we've got 12 as the whole thing, that we know that each part then is 6. There we go. So 12 times 6, which gives us 72 centimeters squared. Then we've got area of, I'm not going to do the quarter circles because we know 2 quarter circles added together is a semicircle. So I'm just going to go straight into the semicircle. There we go. And that's half, because we're not looking at a whole circle, pi times 6 squared. Now 6 squared is 36, half that is 18 pi. If I type that into my calculator and find out what that actually is. We've got 56.54866, blah, 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 blah. Now it says work out the area of the shaded, work out the shaded area. So we're going to have to do that whole rectangle, which is 72, and we're going to be taking away that 18 pi. So 72, take away 18 pi, and that should give you 15.45. It doesn't tell us what to put it in, so you could leave it to that. Centimeters squared, and then I would say to 2 dp. There we go. And that's that question done. Last question. This is the hardest one I found, and it's probably not even that bad because it looks okay. Okay, so you've got the cross section of an earring is a semicircle with a center C and the radius of 25 millimeters. The earring is black and white. The shaded area is black. Sector BCD is white and has a radius of 12 millimeters. And that's shown on the other side. And it says, is more than 20% of the semicircle white? Let's have a look. So because we're looking at essentially area in this question, the first thing we need to do is find out the area of the black one and then find the area of the white one. And then we can do a percentage of the two. I might do the white one first. Yeah, I might do B, C, D first, actually. Again, hopefully you've already paused this, but if you haven't, sorry, pause it. So we're going to do 12 squared times by pi times by 150 over 360. Again, it doesn't matter what order it goes in. Some people freak out when I do a random order. It really doesn't matter. I think as your confidence grows, you'll feel a bit like, oh, I forgot to write that bit. I'll just write it at the end. So that gives you 60 pi. Again, leave it in pi form. It just makes your life easier towards the end. And then finding the area of the black one. So 25 squared times pi. And that's half, isn't it? Because it's a semicircle. Pi r squared. Just checking the units then. So sometimes the units will throw you off. So I think A to E, I'm just going to write that. So that's 215 over 2 pi. There you go, just so you know what I'm doing there. Now, to do them as a thing, we're going to have to put them over each other to find out the percentage, okay? So we're going to do 60 pi over the 625 over 2 pi. Best way to do this, if you're struggling with your calculator, is put it as the decimal version. If you are struggling how to write that into your calculators, whoa, that's not an 8. That's not what I meant to do. There you go. Pen. Got a thing covering my side of my computer at the moment. Probably not ideal. But if you wrote that in, that would probably give you the same style of it. But I tend to just write in my answer now at the bottom just to make my life easier. And that gives you 24 over 125, which is 19.2 So no. Obviously, you probably won't write no. You just write no, not so no, but that will do. So that is areas of a sector and your arc length. Hope that helps, and let me know if there's anything that you would like to see. Just comment below. There you go.